Logistic regression is used to test the relationships between the dependent and independent variables when the dependent variable is categorical. This is different than linear regression, where you have continuous variables that are plotted on a y and x axis, and you can test for the relationship. In binary linear regression, there's only two responses: yes, no, true or false, and they're coded as 0 and 1. And the way the stat works, it's testing the logit function. That's why it's called logistic regression. Between those two, it's testing the probability of those responses. There are three types of logistic regression: binary, where the dependent variable has only two levels, so it's yes, no, true or false; ordinal, where the dependent variable is an ordinal variable; and multinomial, where the dependent variable is a nominal variable that has more than two levels. In all three types of logistic regression, the independent variables can be nominal, ordinal, or scale variables. Assumptions in logistic regression: first is that there is independence between the dependent and independent variables. Another assumption for all statistical tests is that it's the right test, that you're testing for the relationship between the variables. Concepts to keep in mind, again, with all statistical tests: the understanding probability, and also the odds ratio, the likelihood of the event versus the likelihood of the reverse, or the null response. Some key terms or tests used in logistic regression: first, you have the Wald statistic. Wald is the test statistic in logistic regression. It would be comparable to the T statistic in a t-test, or the F statistic in analysis of variance. Logistic regression uses what are called pseudo R-squared. There's two of them, Cox and Snell, and the Nagelkerke. They're very similar. They're on different scales. Cox and Snell goes from 0 to 0.75, while the Nagelkerke goes from roughly 0 to 1. So it's much more similar in scale to a typical R-square value. They're not exactly the same as the R-square used in the least squares method in linear regression, but they're roughly analogous. And finally, the Hosmer-Limachow goodness of fit test. Okay, so let's see how this works. I have a data set here with some blood pressure data. We're going to start with binary logistic regression, and my dependent variable is going to be this variable here, followed protocol. You'll notice that I have it coded as zeros and ones. So the 1 is followed the protocol, 0 is didn't follow the protocol. And I also have it coded as a nominal variable. So to run the binary logistic regression, you're going to go to Analyze, Regression, and Binary Logistic. I already have this set up, so I have the followed protocol selected as the dependent variable. And then I have, for demonstration purposes here, I have several different types of variables. I have a variable called BP class, which is an ordinal variable of normal, prehypertension, and hypertension, so 3 levels. I have 2 blood pressure variables. These are continuous or scale variables. And then finally I have gender as a categorical variable. So SPSS will figure it out that gender is categorical with 2 levels, so you don't have to do anything special. But for this other variable, BP class, you will have to tell SPSS about this. So you click on categorical and you'll select BP class so that it can identify this as a categorical variable, and you can even put in which of the variables you want to serve as the reference variable. Click continue here. Go to options, and here I'm going to select the Hosmer-Limachow goodness of fit test, and I'm also going to select the 95% confidence intervals for the odds ratio. I'm going to click continue, and I'm going to... Okay, so let's take a look at the output. So we first start with just what we've done here. So in our syntax, just a refresher, we have a dependent variable followed protocol. And then we have 4 other variables, 2 continuous, 1 nominal, and 1 ordinal. And we use the enter method. Our case processing summary will tell us a little bit about our data, how the dependent variable is coded. An important part of the logistic regression model is the block 0, which is basically the null model. It's the model without any variables. And you can see you have a classification here. So it's showing us where our variables sit. We have our walled statistic, and it is statistically significant, so that's good news. That means we're likely to have a good model here, and we have our odds ratio. It'll also then list the variables not in the equation, which in block 0 will be all of the variables. In block 1, we use the enter method, so we pushed all of the variables into the model. In our model summary, we have our 2 pseudo R-squares, the Cox and Snell and the Nagelkirche, and you can see that the numbers here are pretty small. Our Hosmer-Lemonischow test is not statistically significant, and that is a good thing. We want this to be greater than 0.05. Our classification model, however, is exactly the same as it was in block 0. So this model, this is just simply a demo model here, but this model does not really add much to the predictive value of these variables. And then finally, we have the variables in the equation. So you can see here there is a significant relationship with blood pressure class, although you'll notice that it is only in the first class, but not in the second class. With the systolic and diastolic change, there is no relationship with systolic change, but there is with diastolic change. And then finally, there is not a relationship with gender. You can look at the SIGs here. You can also look in the confidence intervals. If the confidence interval includes 1, then it's not going to be statistically significant. Now we're going to run the ordinal logistic regression. So we're going to use the same data set. We're going to analyze regression. And now you're going to select ordinal regression. And we're going to put that BP class variable in my dependent list. With the ordinal regression, you have 2 boxes, one for factors, one for covariates. The basic rule of thumb here is the nominal and ordinal the categorical variables you're going to put into the factors box, and the scale or continuous variables you're going to put into the covariates box. And the ordinal logistic regression also begins with a case processing summary of our variables. We have our goodness of fit tests here, which are statistically significant. They are below 0.05. And we do have our pseudo R-squared. We have a Cox and Snell, a Nagelkirche, and then also a McFadden test. And then finally, we have parameter estimates similar to the binary logistic regression with the walled statistic, sig values, and 95% confidence intervals. And finally, we're going to run the multinomial logistic regression. Same data set, go to Analyze, Regression, Multinomial. And now, instead of the ordinal variable, I'm going to put in a nominal variable region. So I have 4 regions of the country selected here. And again, I have 1 categorical variable gender and 1 scale variable age. And I'm going to select my pseudo R-squared, my goodness of fit test, likelihood ratios test, and click continue and click OK. And finally, the multinomial logistic regression output begins with case processing summary, a breakdown of our nominal variable region and our gender variable, followed by the model fitting information, our pseudo R-square values, and then finally the parameter estimates for each of the regions.